Hey everybody, so we're going to be talking about proving angles congruent today. And we're going to start off with a couple of theorems, and then we're going to do some two-column proofs using these theorems that we have just learned about. We're also going to be using our equality properties and sometimes even our segment proof properties and theorems. All right, the first one that we're going to do is the vertical angles theorem. So the vertical angles theorem, it's pretty basic in that it says vertical angles are congruent. And well, you already knew that because you know the definition of vertical angles, which means, and I want you to mark up your picture, you can see that angle 1 and angle 3, these two are vertical angles, which means they are congruent. So we're going to write angle 1 is congruent to angle 3. And you would write the reasoning for this as the vertical angles theorem. You can also see, by the way, that angle 2 and angle 4 are vertical angles, so you could also write this additional congruency statement if you would need it for your proof. Pretty much your proof, you want to use whatever you can and whatever you get from the images or the given and use it to your advantage. Oops, and my parentheses kind of dropped down here. So, oops. All right, next we've got the congruent supplement theorem. Now the congruent supplement theorem says that if two angles are supplements, meaning that they add up to be 180 degrees of the same angle, or of congruent angles, they don't have to be right next to each other, then the two angles are congruent. So pretty much what that means, say if angle 1 and angle 3 are supplements, and angle 2 and angle 3 are supplements. So let's draw a picture. We've got angle 3, and say you've got angle 1. Now, they can be the same. They can share rays. They can be sharing opposite rays. So you have X, Y, and Z. All right. So angle 1 and 3 are supplements, okay? But angle 2 is also supplementary to angle 3. Well, what you'll notice is that 180 minus whatever angle 3 is going to be the same regardless of whether it's angle 1 or angle 2. So therefore, you can say that angle 1 is congruent to angle 2. All right. Now the same thing happens here for our congruent supplement theorem. I'm sorry, our complement. Except the only thing that's different here is that now we're going to be talking about 90 degrees. It's going to be the exact same thing. All right, so now say you've got if angle 1 and angle 2, are complements. So you've got angle 1, you've got angle 2, they're complements. So pretty much saying that the measure of angle 1 plus the measure of angle 2 is 90. All right. and angle 3 and angle 2 are complements. Let me move this over a little bit. There we go. So what that means, that the measure of angle 3 plus the measure of angle 2 is 90. Well, you'll notice that if you get rid of the measure of angle 2 here, right? 90 minus whatever the measure of angle 2 is going to be the exact same whether you're solving the measure of angle 1 and the measure of angle 3 if it's the exact same angle, which means that angle 1 is going to be congruent to angle 3. And those of you wondering, remember the equal sign and the congruent sign, those are not the same thing. Equal means that it's exactly the same thing no matter what. So 3 equals 3. Whereas congruent means that they have the same properties, but they have different names. So angle ABC is the same thing. It's congruent to angle DBA, meaning they've got similar properties, but they're not the exact same angle. All right, next up, we've got the right angle congruent theorem. Now this one, you're gonna be like, why did I even have to waste my paper on this? Again, all right angles are congruent. Well, yeah, think about it, right? Say you have angle 1 and angle 2, and they are both right angles. All right, well, we've got angle 1. And let's turn this one upside down. They are right angles. Well, that means they're both 90 degrees, by the way. And because they're both 90 degrees, we can say that angle 1 is congruent to angle 2. And think about it. Of course, they're all going to be congruent. A right angle is 90 degrees, no matter what you call it. All right, next up, you've got our supplementary right angle theorem. Now, this says that if two angles are congruent and supplementary, so they have to be both, then each is a right angle. So, think about it. If you've got angle 1 is congruent to angle 2, and angle 1 and angle 2 are supplements. So if we're drawing a picture, that means, remember, a supplement means that they're going to add up to be 180. So we're going to draw a straight line or a straight angle. And they're being congruent, which means we're splitting that 180 into 2. And if 180 divided by 2 is 90, which means both of them are going to be right angles. So we can write that the measure of angle 1 is 90. The measure of angle 2 is 90. Therefore, angles 1 and angle 2 are right angles. So now we're going to use these to write our proofs. And those of you tuning in, some of you I had asked, you need to figure out example 1. Well, here it is. All right, so given example 1, all right, the measure of angle 1 is equal to the measure of angle 3. So they've given us this part right here. And we need to prove that the measure of angle AEC right here, I'm going to highlight it, AEC is congruent to DEB. All right. Well, you'll notice in our highlights right here, that angles 1 and angles 3 right here, well, they're the exact same. All right. But angle 2 right here, that's the one that they share. And we need to prove that angle 2 is congruent no matter what. So let's start off with what we've got. So we're always going to write what our given is first. All right, so we know that the measure of angle 1 is equal to the measure of angle 3. All right, well, what we also want to do is note that the measure of angle 2 is equal or congruent to the measure of angle 2. Well, yeah, we know that, and that's because we're using the reflexive property. Think about it this way. When you have good reflexes, it means your arm can come back to you, or your leg, your knee can come back to you. That's what reflexive means. It reflects back. It comes back to you. It's the same exact thing. With symmetric, think about it this way. It's symmetric on the opposite side of the equal sign. So if you've got a B here, you're going to have a B here, and on the opposite, it's going to be symmetrical so that if you fold it pretty much, it would end up being the same. All right? Well, now what we can do, we can use our first statement, and we're going to add the measure of angle 2 to both sides. And when we're doing that, we're using our addition property. All right, now that we've got our addition property and we know that angle 1 plus angle 2, okay, is equal to angle 3 and angle 2. We've got our in terms of our numbers, but now we have to do it in terms of our letters. So we're going to have to state using our angle addition postulate, and I'm going to write this in a different color so you can see that it's going to be the reasoning for both. So what that means is we can say that the measure of angle AEC is angle 1, the measure of angle 1, plus the measure of angle 2. We can also say that angle DEB is equal to the measure of angle 3 plus the measure of angle 2. Well, now, using our angle addition postulate and our substitution property, we can say that this right here so notice the measure of angle 1 and the measure of angle 2, it's the measure of angle AEC. So we can replace the measure of angle 1 plus the measure of angle 2 with AEC. And we can do the same thing here with the measure of angle 3 and the measure of angle 2 with angle DEB. And hey, look, that was our proven. That's what we have to prove. You will always arrive at that proof, and that's going to be your final step. All right, so now let's go ahead and do example 2. By the way, if you did need to say it was asking you to prove it, that measure of angle AEC was congruent to measure of angle DEB, whew, that's a mouthful. then you would say that exact same thing, but you would say the definition of congruence. And that would be your proof that now these two are congruent. But we don't need to do that. Not for this one. All right, so now let's go ahead and do this next one right here. All right, so you have been given that angle 1 is congruent to angle 4. Sorry about that, guys. Those are the bells, in case if you're missing school. All right, so first things first, we're going to write our given, which is that angle 1 is congruent to angle 4. And I want you to mark up your graph right here, or your diagram. So angle 1, oops, I have that written wrong. Nope, that's good. So it says that angle 1 is congruent to angle 4. All right, well, what we can also tell is that we have a lot of vertical angles because of them being on opposite rays. So I'm going to go in and notice that angle 1 and angle 3 are also congruent. But angles 2 and angles 4 are also congruent. So I'm going to write it in with both statements. So angle 4 is congruent to angle 2. And angle 1 is congruent to angle 3. And for both of them, it's going to be the vertical angles theorem. You can also say definition of vertical angles. It's going to be the same thing. And I'll take both. All right. Well, that's great. But we need to prove that angle 2 is congruent to angle 3. Well, what you can do is you can substitute, well, you can use a transitive property here. If angle 1 is congruent to angle 4, and angle 4 is congruent to angle 2, then we know that angle 1 is congruent to angle 2. Well, we still need to put that angle 1, we still need to get it to equal that angle 2 is congruent to angle 3. Oh, what if we use our symmetric property right here? And our symmetric property, it's going to be the same thing, but all we're going to do is we're going to swap the sides. Oops. All right, and now, oh my goodness, I do believe we can use our transitive property again. You can also use substitution for this. Either or will work in this situation. I'm going to show you with transitive first. So angle 2 is congruent to angle 1, and angle 1 is congruent to angle 3. Then you can say that angle 2 is congruent to angle 3. And you can say transitive property. Now say you were doing it with substitution. Angle 2 is congruent to angle 1. This is where we last left off. Well, you'll remember that angle 1 is congruent to angle 3, which means I can drop that angle 3 in there because they are congruent to each other. And you can say angle 2 is congruent to angle 3 using substitution. I would take either of those two. All right, thanks for watching.